Okay, video number 3. New baby heading, writing a definition as a biconditional. Remember, biconditional, if and only if. So, how this works. This is your example 1 directions. So, or your directions for the whole video. Test each statement below to see if it was reversible. If so, write it as a true biconditional. If not, write not reversible. Now, how in the world are we supposed to figure out if it's reversible? I just realized that I spelled reversible wrong. Oh my goodness. And what's so bad is I spelled it right in one place and then wrong in the other. But anyways, moving on. Okay, so how do we figure out if it is reversible? What does that even mean? Well, whenever you're given a statement, to figure out if it is reversible, you need to write that statement as a conditional. So if then, that you already know how to do. And then you need to take that conditional statement and write the converse. So converse is still an if then. You just switch your hypothesis and conclusion. Now, if both your conditional statement and your converse statement is true, then you can say that your statement is reversible, which is like, what? But anyway, let's look at an actual example. So, example 1, a quadrilateral is a polygon with 4 sides. Okay, this goes back to Friday. You're given a statement and you have to write it as a conditional. So if we write it as a conditional, it should be somewhere along the lines as this. If a shape is a quadrilateral, then it is a polygon with 4 sides. Okay, somewhere along that line. The first part of that if should be talking about a quadrilateral, and the second part of that then should be saying something about polygon with 4 sides. So after you write your conditional, go ahead and write your converse. Converse, just switch hypothesis and conclusion. So your converse is, if a shape is a polygon with 4 sides, then it is a quadrilateral. Whew. Okay, sorry guys, I'm like coughing my head off every time I pause the video. Okay, so now before we can figure out if it's reversible, we have to figure out if the conditional and the converse are both true statements. So looking at the conditional, if a shape is a quadrilateral, then it is a polygon with 4 sides. Now, this is actually, we get to this later, but you should hopefully know enough about this to figure it out. So, a quadrilateral, by definition, quad means 4, so it has 4 sides. Polygon is a closed figure with 4 sides. So, by definition, a quadrilateral is a polygon with 4 sides. So, our conditional is true. So the converse, if a shape is a polygon with 4 sides, then it is a quadrilateral. So what that's saying is every polygon that's 4-sided is going to be a quadrilateral, which is true because, I mean, you're probably thinking of a bunch. Square, rectangle, rhombus, trapezoid, they're all 4-sided polygons, but they're all quadrilaterals. Quadrilateral is like, when you say cars, you just picture all kind of cars, but a BMW is a specific car. Well, quadrilateral is all kind of 4-sided shapes. It's just squares are specific 4-sided shapes, which we'll get to that in, I believe, chapter 6. But anyway, so both the conditional and the converse are true statements. So we can write the biconditional. Remember, biconditional is if and only if in the middle. No more if-thens, only if and only if. And then you're going to put your hypothesis on one side and your conclusion on one side of that if and only if. So when I go to write biconditional, again, I can do it 2 different ways because you can read the sentences 2 different ways. Biconditional, a figure is a quadrilateral if and only if it is a polygon with 4 sides. Okay. Second way, a polygon has 4 sides if and only if it is a quadrilateral. So all I did was took that hypothesis and conclusion and put it with my if and only if here. Put hypothesis on one side, conclusion on the other, and then switched. Okay, example number 2. So same directions, pause, try this for yourself. You should already pause this. Okay, a straight angle is an angle that measures 180. So to figure out if this is true, we need to write it as a conditional and write it as a converse and see if they are both true. Conditional, if an angle if an angle is straight, then it measures 180. Okay, converse. If an angle measures 180, then it is a straight angle. So now we need to figure out if each one is true. So if an angle is straight, then it measures 180. Well, yes, by definition of a straight angle, it has to measure 180. Okay, converse, if an angle measures 180, then it is a straight angle. Yes, we may call it something different sometimes, but still by the definition of measuring 180, it has to give you that straight angle. So whenever you write a biconditional, again, there's two ways. An angle is straight if and only if it measures 180. And two, if an angle measures 180, then it is straight. What? No, that is wrong, folks. Hold on while I fix my error. Okay, I fixed it. The second one should say an angle measures 180 if and only if it is a straight angle. Excuse me, I just copied down the I don't know what I did actually. So that's the answer to the example you should have nailed by yourself. So this was video 3 of 4. So go watch that last video and then you'll be good to go.